The length x millimeters of a certain species of seashell is normally distributed with mean 25 and variance sigma squared. The probability that x is less than 24.15 is 0.1446. This problem is normally distributed because we have here the length and it's a continuous variable. So it's normally distributed with a mean of 25 and a variance which is unknown. Okay, let me continue. A random sample of 10 seashells is collected on a beach. Let y represent the number of seashells with length greater than 26 millimeters. So y here, the variable, is discrete. So we have y is binomially distributed with n. How many n do we have? 10. And probability is not given yet. Okay, maybe we'll solve that later on. The first problem, we have to find the probability that your x, which is a normal distribution, that x is greater than 24.15 and less than 25. We can do that by, we can visualize a problem. So we have here our 25, and then here is 24.15, and it says that the probability of x is less, the probability that x is less than 24.15 is 0.1446. Okay, for this we need to find this point, probability that is less than. So we're looking for this area. So probability that our x is greater than 24.15 but greater than 25. So as you can see, we can simply use subtraction from this point to this point where the mean is, that comprise 50%. So we can have 0.50 minus 0.1446, and that's equal to 0.3554. Okay, you can put that in 3 sig fig, so 0.355. Now the question is, can we use normal CDF from this point to this point when we do not know what the standard deviation is? The answer is yes, we can, but here we are going to use C-scores instead. Okay, we convert this, so we will have our C-score. In C-score, our mean shall be 0, and then we look for the C-score of 24.15 using inverse normal. It will require you to write the area. The area is 0.1446. Now, our mean is 0 because we are now using Z-scores. Our standard deviation is 1. These are default in your calculator. This will give you a Z, which is equal to negative, let me check my calculator, negative 1.05988. You can save this. Now, let's use the normal CDF. So the normal CDF will be from this point where your C is up to this point up to this. So from Z to 0. So when you use your CDF, you will be asked to give your lower bound. So your lower bound is negative 1.0598, etc. And your upper bound is 0, your mean is 0, your standard deviation is 1, you will still be getting an answer which is 0.3554. Okay, so that's it for letter A. Let's move to letter B. Let's solve letter B, point 1. Find the standard deviation of random variable x. So we will be using the formula for standard deviation, which is equal to raw score minus the mean over z. We have already solved c previously, so let us substitute the value. Okay, by the way, let us try to visualize a problem where this is 0 or 25, and we have here this is negative 1.05, the equivalent of 24.15. So let's use 24.15 minus 25 over z, which is negative 1.0598. Now our standard deviation is equal to 0.80197,892. To trace it quick, we have 0.802. Now we find the probability that a seashell selected at random has a length of greater than 26. So this is 25. Let's say we have here 26, and we're still dealing with length. So this is still normal. So we're looking for this probability. So the probability that is greater than 26 is here. So we look for the probability that your y is greater than 26. So are you using normal or binomial? Again, it's normal because we talk about length. Next question, are you going to use PDF or CDF? It's going to be CDF because this is the area you're looking for. It's cumulative. So in your calculator, you will encode the following. It will require you to give you the lower bound. So your lower bound is 26. Your upper bound, since it's normal, it's continuous, it's positive infinity, and you're dealing with raw score, so your mean is not 0. You use 0 when using c-scores. So your mean is 25, and your standard deviation is the one you have solved a while ago, 0.80197. I hope you saved that so you don't have to copy the digits one by one. So the probability of this calculator will give you a certain answer, which is the probability. And that probability is equal to 0.106214 and more. Let's just round this to the nearest to the nearest three significant digits. It's equal to 0.106. This is significant. Let us solve letter C. It asks for expectation of the mean. So expectation is related to binomial distribution. So let's go back again here. We have y is binomial distributed with parameters n equals 10 and p probability that is greater than 26. We have solved that previously. So that's 0.802. 0.106. I hope you copy that because you just write here 0.106, but in the solution we will be using the original value. So expectation of y is NP. So let's substitute the values for NP. 10 times 0.1062, etc. So this gives us 1.0621, etc. And please intrinsic fig we have 1.06. For letter D, we find a probability that exactly 3. So for letter D, it's a probability that your y number, y is the seashell, number of seashells, that y is exactly 3. Find the probability that exactly 3 of the seashells have a length greater than 26. So exactly 3 of the seashells, are we using normal or binomial? It's binomial. So if it's binomial, are we using PDF or CDF? We are using PDF with this word. So in your calculator, you will encode for binomial PDF, you will encode the following. It will ask you the number of trials, which is 10, the probability of success for this, which is, this is previously encoded, 0. What is this again? 10621, etc. And then it will ask you for the value of x, which is exactly 3. Now this will give you this answer, which is 0.06551850, and so on. You can adjust the float so you will know, you will have the digits you want to be displayed in your calculator. So this is 0.0655. For the last problem, a seashell selected at random has a length less than 26 millimeters. Find the probability that its length is between 24.15 millimeters and 25 millimeters. Another way to put that problem is to say that we're looking for the probability that your y, the seashell, is between these values. So it's greater than 24.15, but it has, that seashell has a length that is less than 25, given that. So given that, that's the first condition, that your y is less than 26. Okay, regarding the length, this has already been solved in part A. We know this to be 0.3554. You can look it up. But then for letter B, this one is, we're looking for, this one gives you the probability that y is greater than 26. But what we're looking for is less than 26. This has the value of 0.106, again referred to your previous solution. So to get the probability that your y is less than 26, just looking at the complement. So here, but now you're looking for something that is less. So, and the whole thing is 1. 100% is the perfect probability. So that's 1 minus 0. Let's say this is 0.106. So 0.106. So we have here 1 minus 0.106. And the answer to this is 0.397634, etc. So 3 sig fig 0. 398.